Pacific region from Trina Solar. And before he kick off his presentation, I would like to give you a brief intro about Andre. Andre is a leading Trina Solar Asia Pacific region's TrinaPro business and is an accomplished energy and product management professional with over 12 years experience within the European, Asia, and Australia solar PV sectors. He has worked across a variety of disciplines within both utility scale and CNI, excluding roles in business development, cost estimation, project engineering and management, new market entry strategy, new product introduction, and O&M. He's also a accredited designer for grid-connected PV systems by the Clean Energy Council of Australia. He's going to deliver lowering risk and enhancing financial returns with Trina Tracker. David, are you able to share a screen now at the start of your presentation? Thank you.
Sure. Thank you, Jessica. Let me just share. Can you see my screen?
Yes, I can see your screen now.
Yeah. Okay.
Great.
Thank you, Jessica. Well, good morning, good afternoon, everybody, wherever you may be. My name's Andrew Gilhooly. I'm, as Jessica says, the head of Trina Tracker and Trina's utility solution sales in Asia Pacific. So I'm based in Melbourne, Australia, but we manage obviously the Australian market, India, Vietnam, some of the other Asian markets, including the emerging Central Asian markets in Uzbekistan and Kazakhstan, right the way over to Israel. So it's a pretty big patch, but we've been very, very excited and privileged to be participating in the Israel market, especially very exciting with all of the developments in the market about the solar and storage tenders. So we're very excited, and we're very lofty ambitions to push our tracker solution into the Israel market. So I'll just start briefly a bit about Trina Tracker within Trina. So back in 2017, Trina acquired 2020 Trina acquired a controlling stake in Enclave, who were always in the top 4 or 5 globally in terms of tracker shipments. Back in, sorry, that was 2018. Then in 2020, Trina acquired 100% of Enclave and rebranded to Trina Tracker, and launched a couple of new products that we'll see briefly. But yeah, Trina is unique. Trina Tracker is unique because it's the only tracker solution with one of the Super League Tier 1 module manufacturers who also provides a truly integrated tracker solution. So superlative in terms of bankability. The Trina Solar parent is listed on the warranty certification. So we think that provides our customers with much more confidence in the long-term support that Trina will be around to support you for the entire asset lifetime. We've now deployed over 7 gigawatts over the best part of 12 years into every major global markets with numerous production centers worldwide. And we have full DNV bankability reports on our tracker technology. Recently, we were announced as actually the 6th consecutive year being the most bankable brand in the solar industry. So we like to position our tracker as being the most bankable solution that unlocks the highest and most assured long-term energy outcome for our customers. We have a couple of different tracker products. So we'll be focusing on our Vanguard, which is where we have 2 modules in portrait. Now, importantly, Trina Tracker is, as I say, the only tracker solution that's available from a module manufacturer. Trina itself, as you'll see with my colleague Lim shortly, we're the first mover into the large format module space. And our modules are low voltage, so we can run long strings, up to 40 modules in a string of the 550. So we specifically engineered our trackers to accommodate these ever increasingly large modules, up to 670 watts, in fact, and up to 40 modules in a string in these longer north-south distances. So the trackers are fully engineered to accommodate these large modules in a structurally adequate fashion. The 2 portrait is a single row tracker. There's 2 modules in portrait over the pivot. So we really amortize and utilize the steelwork really effectively. So you'll see here there's only 7 foundations per tracker. On a per megawatt basis, that equates to, when we use our 650 watt modules, as few as 100 piles per megawatt. So a very big construction saving compared to other one portrait trackers that need between 250 and 300 foundations per megawatt. And when you have to pre-drill and concrete, that just really turbocharges your construction savings. Also, there's no mechanical linkages east to west. So there's a superior slope tolerance with this tracker, 15% in any direction, and actually up to 30% with using our patented spherical bearings. And we have a unique multi-point drive system that we'll see later on that really guards against any possible dynamic effects with these large modules in service. So we say that this tracker is the best for challenging sites, either sites that are quite rocky or uneven terrain, even sites that are prone to flood inundation, or as we'll see shortly, we recommend this tracker for projects that are co-locating solar trackers with agriculture. We also have our agile one portrait tracker. That's where there's one single module in portrait, and there's one row that is motorized with a slew drive gearbox connected via a rotating mechanical shaft only to one neighboring row. So you have completely unimpeded vehicle and trafficability access on 50% of the rows. And you can remove this connection very quickly if you need to for O&M or vegetation management. But because these trackers are at one portrait, they're a bit closer to the ground. So the steelwork, the sections can be a little bit lighter and more optimized for slightly lower winds. So this tracker is a little bit cheaper on a supply basis. So we say that this tracker is better for the sites that are less challenging, maybe they're flatter or not quite as rocky. And then we say the two portrait is the way to go for the more challenging sites. These are just some of the examples of some of the challenges we see on our construction sites. So maybe sites that are irregular in terms of boundary, or especially sites like in Israel, where many sites are being installed with batteries. You're trying to install the very highest amount of megawatts DC. So all of a sudden that can make sites that were formerly unconstrained pretty tight in terms of area. Also sites that are uneven terrain, sites that are prone to strong winds. Trina Tracker is one of very few trackers to be able to deploy at scale in cyclonic regions. Also sites that are very rocky, or on the other side, cohesiveless, where we have to embed the foundations 3 to 4 meters deep in some cases, where we have fewer piles. That really mitigates that cost penalty. And also sites that are incur high corrosivity. So this is the two portrait tracker. You'll see that we have a central master actuator that's linked to two neighboring actuators via a rotating mechanical shaft with universal joints. So they're mechanically synchronized. There's no wireless comms or anything like that. So the tracker is always fully mechanically synchronized. As I say, we've got a really low foundation count. We've had to, from the wind tunnel testing, we've invested millions of dollars with the best wind tunnel consultancies on the planet, RWDI and CPP. That informed us that we had to increase the section of things like our torque tube up to 170 millimeters. The other benefit with the two portrait is they're a bit higher off the ground and a bit more space between the tracker structures. So you get a bit more of a bifacial boost than you would with a fixed tilt or a one portrait. And then we can utilize intelligent tracker algorithms to boost the energy by a further 3 to 8%. So as I say, our trackers are specifically engineered for these larger format modules. You can see in a two portrait configuration, back to back, we're almost at 5 meters, and north to south up to 67 meters. So that's why it's super important, if you are going to use trackers, to partner with a company like Trina Tracker, who've applied all of the requisite due diligence in the wind tunnel testing and working with the right engineering consultancies. We've continued to squeeze every last bit of value out of our tracker as the designs have evolved over time. So you'll see that previously we've increased the length north to south of both of our trackers, but this comes from being able to run longer strings. We can run up to 120 modules in a per tracker configuration, and up to almost 70 meters. And we find that this can reduce installation costs by 25%, BOS cost by 10%, and ultimately LCOE by 2.5%. We can also incur some considerable civils, grading and cut and fill costs as well from the spherical bearings that we use, and also from having fewer piles. Ultimately there's 20% saving compared to other two portrait trackers. With our one portrait, this is a closer view. So you can see the Slew drive gearbox here with a small DC stepper motor that's bolted on, only a couple of fixings there, and a rotating mechanical shaft there. So yeah, some benefits here, but we have spherical bearings. Because we only motorize 50% of the rows, it reduces the number of motors, of drivetrain components, of tracker controllers by 30 to 40%, which ultimately saves on supply cost and also installation capex as well. This is what our spherical bearing looks like, and this is how we're able to unlock sites that were formerly unviable due to terrain considerations. This is patented and is unique to Trina Solar. And we also have a Trina clamp that can reduce the module fixation time by up to 50%. And because our tracker form factors are shorter north to south and wider in an east-west direction, we find that we can attain a better land utilization than other trackers in the same area. That's important in Israel, where many projects are going ahead with batteries. You're trying to install the very highest megawatt DC. So we can install more megawatts in the same footprint or as other trackers, or the same megawatts but at a wider pitch east to west, and reduce the shading losses and boost your energy. We were privileged to run some quotations recently, and so we did some value proposition analysis for a particular customer in Israel who were looking at a tracker as compared to fixed tilt east-west, as you see here on a couple of sites. The site on the left was quite constrained. We could only fit 5.6 of fixed tilt. With tracker we could fit, because you need wider gaps between the rows, we could only fit 4.4 megawatts. And on a slightly larger site, we could fit 15.6 with the fixed tilt and 12 megawatts with the tracker. Now that seems like quite a big drop in DC capacity, but then when we plug the numbers into our value proposition, we see that through the tracker unlocking 23% more kilowatt hours per kilowatt peak as compared to the fixed tilt, that's a huge gain, right? So even though the tracker was 4.4 megawatts and the fixed tilt was almost 6, we were actually only 2% under 4% under the fixed tilt. But when you consider that we were 15% smaller in terms of or smaller in terms of the 30% smaller in terms of DC capacity, fewer modules to procure and install, less steel structures, less balance of system equipment. Actually, the absolute capex was 15% cheaper. So we were only 4% lower on energy, but 15% lower on total capex. So we lowered the levelized cost by 3.8%. So we're seeing trackers as the silver bullet for developers, especially in Israel, where you're using high balance of system cost applications like batteries. The cost premium of trackers really goes into the noise, and trackers can really mitigate those cost increases that we've seen in modules and in steel and in shipping. You can achieve a very similar energy outcome, but with a much smaller DC system. We also have our proprietary SCADA solution that is able to monitor and control every single individual tracker. We have our smart tracking algorithm that boosts energy in heavy cloud cover and uses intelligent machine learning to vary and continually improve its tracking algorithm to reduce near shading, especially in backtracking. Both of these have been proven independently verified to boost yield by a further 3 to 8% with tracking. And what's really interesting in Israel is these are some images from NREL out of the US. There's really loads of applications for solar and agriculture, but none more so are truly suited to agriculture than the combination of solar and single axis tracking. As you see on the right here, if we use tracking, especially in two portrait, you get much more wider clearance between every row, and we can elevate the trackers much higher off the ground to clear any kind of livestock or large farm equipment running underneath or between the rows. So we'll just finish on a couple of projects that Trina have done in the solar and agriculture space. This is the Tongchuan 30 megawatt project in China under the Top Runner scheme. The foundations were actually elevated to almost 4 meters in the air, and the tracking you'll see boosted the energy considerably over fixed tilt. This is also a 5 megawatt project that Trina Tracker did in Melbourne in Australia for McCain Foods, one of the largest food processing groups on the planet, with our 2-portrait tracker. And you can see really the benefit there of going with the 2-portrait, with having these much wider clearances between every row. We provide deep and close support for all of our customers at every stage of the project lifecycle, from pre-sales on into execution. So even if it's your first tracker project, please don't feel like you're on your own. We are here to support you closely and make it as easy as possible for you. So just to finalize, our technology is very well proven over 12 years and 7 gigawatts, very, very low failure rates. So a very reliable tracker with the most assurance, with Trina Solar parent standing behind the solution. We minimize the construction capex and risk, and we unlock the highest long-term energy outcome for our customers. Thank you very much.
Hi, Andrew, you finished your presentation?
Yes.